All right, so we're going to talk today about factoring quadratics and just a refresher on the box and diamond method. So for example 1, it says factor 3x squared plus 10x plus 8. Okay, so for your box, you're going to put your 3x squared here and your 8 here. Okay, and then we have to go to the diamond to figure out what goes in the other two boxes. And so the first thing you're going to do is you're going to multiply the first and the last thing, so the things you just put in the box together, and you're going to put that product, which would be 24x squared, here. And then you're going to put this middle unused one down here. So the idea is what I'm going to be trying to find are two things that multiply to 24x squared but add up to 10x. And so if I'm going to add these together to get 10x, they have to be like terms. So both of these have to be x's. And when I multiply x times x, I get the x squared. So that's going to be taken care of. So now I just need to think about what two numbers add up to 10 but multiply to 24. Okay, so that would be 6 and 4. And those are the other two things that go in the box. So I'm going to put the 6x here and the 4x here. More about placement in a second. Okay. All right, so then I can take a look, right? If I'm looking at what these two have in common, okay, that would just be an x. And if I'm looking at what these two have in common, right, that would be 2. Okay. When I look at what these two have in common, that would be a 3x. And when I look at what the other vertical column has in common, that would be 4. And you can double check on the outside. If I multiply this 4 by this x, I get 4x. If I multiply this 3x by this x, I get 3x squared. If I multiply this 3x by this 2, I get 6x. If I multiply this 4 by this 2, I get this 8, and so I'm good to go. Those numbers on the outside are the factors. Okay, and so I'm going to go ahead and write my final answer over here as x plus 2 times 3x plus 4, and that would be the factored form. Okay, now some of you, I already know, are wondering about a couple of things, and so I'm going to do my best to kind of answer those questions. I'm going to recreate the box real quick. Let's pretend we had done everything the exact same, so the 3x squared is here, the 8 is there, I'm using the same diamond, but what if instead of 6x and 4x, I did 4x and 6x? Okay, does the placement of those two things you find in the diamond actually matter? All right, well, let's take a look. Okay, so I'd have a 3x in common here. I'd have just an x in common here, right? I would know this would have to be a 2 because 3x times 2 would give me the 6x. And let's see, and up here, this would have to be a 4. And so I would get 3x plus 4 times x plus 2, which is exactly the same answer as I have over there, right? That's when you're multiplying things, the order you write them does not matter. And so either one of those would represent factored form. The other thing I want to mention to you is when you set up your box will be set up correctly if the diagonals multiply to the same thing. So if you take a look, right, here this diagonal multiplies to 24x squared, right, and this diagonal multiplies also to 24x squared, and so I know the setup is correct. Those two diagonals always have to multiply to be the same thing. All right, now that we are kind of better at that, let's cruise a little bit in this next example. So 4x squared plus 17x minus 15. So I'm putting the 4x squared, and I'm putting the negative 15. Remember that I'm multiplying those two things and putting them up top, so negative 60x squared, and the unused middle term on the bottom. So I'm looking for stuff that multiplies to negative 60x squared but adds up to positive 17x. So that would be like 20x and negative 3x. Okay. Again, doesn't matter which one you put where, it will still work out. Okay. So let's take a look. Only x do these things have in common. And since I know I need this lower box to be 4x squared, that means this must be 4x, which also makes sense because 4x goes into both 4x squared and 20x. Okay, here I'm going to pull out a -3 times both. Another way, if you're not sure if it should be negative or not, if this is already an x, then this would have to be a -3 for this part to be a -3x. And then here, since I already have determined that this is going to be 4x and this box is a positive 20x, then this would just be a 5. Okay. So when I write down my factors then, x plus 5 times 4x minus 3. All right, let's keep it moving. Example 3, 4x squared minus 8x plus 3. Okay, so my 4x squared here, my positive 3 here. Again, I'm multiplying those to get 12x squared and negative 8x. That middle term goes on the bottom. So what multiplies to positive 12x squared but adds up to negative 8x, right? You do need to be a little bit careful with your signs. In this case, even though initially it might seem not possible, remember a negative times a negative is a positive. And so I'm going to put negative 6x and negative 2x in here. Okay, so let's go ahead and take a look. I know that I need this to be a positive 4x squared. And so I think what makes sense is to pull out a positive 2x from those, and same down there. Okay, so we'll leave this being all positives. And then what goes for the 3 and the negative 2x is just a -1. Right? And then it makes sense that here I would also have to pull out a -3, since as soon as I determine this is going to be a -1, oops, this is going to be a -1, then to get this positive 3, this must be a -3. Okay, so it turns out that factored form here would be 2x minus 3 times 2x minus 1. All right, we're cruising. Let's keep it moving. All right, for our next example, then, I'm going to put my 3x squared here. I'm going to put my minus 3 here. So when I multiply that, I get negative 9x squared. That's what it has to multiply to. It has to add up to 5x. All right, sometimes if you get stuck, right, one thing you can do is write out all of the factors of this top thing just to kind of see which ones actually work. And so if I do that, I could have 9x and negative 1x. That adds up to positive 8x, so that's not it. I could have negative 9x and positive 1x. That adds up to negative 8x. That's not it. I could have 3x and negative 3x. Well, that adds up to 0, and that's it. But those are all the things that multiply to negative 9. And so what it turns out is there isn't anything that multiplies to negative 9x squared but adds up to 5x. And so no factors of negative 9x squared add up to 5x. So if that's true, what does that mean? It basically means that this is not factorable. Okay. That's a different question than saying if something is possible to solve, right? So I can't factor this. I still could solve it using quadratic formula, but that is not the question I'm being asked. All I'm asking is if I can factor it at this point. All right, so last example for this video. This is a little bit different. Okay, we're used to it being in a ax squared plus bx plus c form. So I could do a rewrite where that middle term, I don't have any x's, and so I'll just call that 0x. So now this is exactly the same kind of problem. So I'm going to put the 4x squared here. I'm going to put the negative 9 here. When I multiply that, I get negative 36x squared. And that needs to add up to 0 x's. So I'm looking for stuff that multiplies to negative 36x squared but adds up to 0 x's. So that would be positive 6x and negative 6x. And then you can just go about your regular business here. So minus 3, let's see, 2x here. If this one's going to be a positive 2x, then this one also has to be a positive 2x. And here, if that's going to be a 2x on the bottom, then this has to be a 3 to get a positive 6x. And so my answer would be 2x plus 3, 2x minus 3. So that's your basic overview of how to use the box and diamond method to factor a quadratic.